γενικώς όποτε μιλάς στο μικρόφωνο είναι ανοιχτά όλα. Έγινε.
Good morning. Welcome to the Hackathon event organized by the EuroCC Cyprus. Today is a very special day because this event is organized for a good cause in collaboration with Cyprus Anticancer Society. As I said, this event is organized by the EuroCC 2 project. And let's welcome to the podium Professor Dovrolis.
Okay, Kalimera, welcome. Good morning, everybody. Thank you very much for being here. Many thanks to our friends from the Anticancer Society of Cyprus that it is really thanks to them, thanks to their help with the data that they provide, that this hackathon is feasible. So we hope to actually produce something that is useful for you, and we're looking forward to further collaborations. There is a lot to be done in general in the area of health now that we have all of these sophisticated AI tools. And I truly believe that we can actually work very productively together. So thank you all very much for being here. Also, we have some remote participants that are going to actually participate in the hackathon. So welcome to those as well. I want to just say, I will not take much of your time. I want to just say a few things about the Cyprus Institute, CastorC, which is our research center, and the EuroCC project, which is actually sponsoring this event, right? So just to give you a brief introduction. So as you know, we are at the Cyprus Institute. The Cyprus Institute is a research and academic organization in Cyprus, non-profit. We have a number of research centers in climate change, water and energy, cultural heritage. Our research center is focusing on computational science and technology. It's called CastorC, right? And some of the things that we do in this research center are machine learning, high-performance computing, simulation, multi-scale simulation, high-performance data analytics, network science, and various other things such as computational physics, computational fluid dynamics. And recently, actually, we also have a project in quantum computing. So that's a new thing for us. So these are some of the methods, the tools that we're using. The applications can be anything from computer vision applications to the design of new materials, bioinformatics, analysis of things like proteins and so on, climate modeling, social networks, things that have to do with fundamental physics. And again, this is a quantum computer. So a few words about the center. We are a relatively small research center, about 6 faculty members, 30 researchers. We also have PhD and master's students. We're doing quite well in terms of funding, both European funding and national funding. And we have, as I said before, a lot of partnerships and collaborations internationally with Europe and other places, including our founding partnership with the University of Illinois in the US. Additionally, CastorC is well known for its history in high-performance computing. So we're hosting here the National High-Performance Computer of Cyprus called Cyclone. And CastorC is considered the National Competence Center in High-Performance Computing. So this is an official role that we're playing for Cyprus in the area of high-performance computing. So additionally, because of this role, we participate in this project called EuroCC. This is a pan-European project that I will describe in the next slides. And through this project, we are organizing many different things, such as training events, this hackathon, partnerships with companies, and so on. Over the years, we have worked, Cyclone has been used not only in Cyprus, but also from researchers in other countries in the region for many different types of projects, as you can see here. Now, let me say a few more things about EuroCC, right? This pan-European project that focuses on high-performance computing. What is the goal of the project? The goal is to basically promote the use of high-performance computing in the different European countries, right? So we focus on Cyprus. We try to promote the use of high-performance computing in the Cypriot ecosystem, and that includes small companies, large companies, public organizations, academic organizations, right? We try to establish many different partnerships so that we can use high-performance computing, high-performance data analytics, machine learning. We can use all of these nice technologies to actually do something useful, right? And when I say something useful, it has to be useful for the local economy. So Cyprus has its own national strategies and national priorities, and we have to kind of take those into account and work in those directions. Additionally, it's very important to do things that have a socially good impact, right? It's not about only increasing productivity, increasing efficiency. It's also about things like what we do today, which is to perhaps end up with something that will be useful for cancer patients. So I will not tell you much more. I already talked about our machine called Cyclone. What has been happening in the last few years, of course, is a revolution. You all know about, I'm sure, ChatGPT, right? Probably you're using it. The revolution that has happened is in the area of generative AI, right? Now we have tools that, if I would describe them to you 5 years ago, you would say that this is science fiction, that it's not reality. But now it's reality, right? And what we designed the hackathon so that it can take advantage of this type of technology, right? The hackathon, we expect you to actually work using large language models and produce solutions that are capable to take advantage of generative AI. So again, as I mentioned, the EuroCC project allows us to do various collaborations with the local ecosystem, including trainings, consultations, proof of concept development. We work with a number of different partners from the private world as well as the public, the government organizations. Let me just mention an example of a collaboration that we do with the German Oncology Center. They are very interested, they have a lot of experience and a lot of data about prostate cancer. They also have developed methods, quite innovative methods for the treatment of prostate cancer. So we're working with them on problems that relate with the detection of cancer, as well as segmentation of the prostate, so that they can apply those innovative treatments like brachytherapy with radioactive materials and so on. This is, it's a little bit old, so there are a couple of new people that I apologize, they're not on the picture, but this is the EuroCC team in Cyprus. It includes of experts in many different aspects of high-performance computing. Some of them do machine learning, some do simulations and so on. And many of them are in the room. They are going to be helping with the hackathon in different ways. So this is pretty much what I wanted to say, just as an introduction. We will hear from Kyriaki that has done a lot of work for this hackathon. Thank you, Kyriaki. And we will hear also from Yorgos, Chris. They will tell you different things about the hackathon. And of course, we will hear from the folks at the Anticancer Society. They will give us the human element of this and why we're doing this. What is the real impact, right, for this hackathon? So thank you very much. If you want to, ask me any questions, have any ideas about future hackathons or any other collaborations, you can reach me at that email. Okay. So thank you very much. I hope we will have fun working on this hackathon.
Thank you, Konstantin. Hello again. As I said before, my name is Kyriaki Gilili, and I'm an associate research scientist at the Castor C, as well as training and skills development and task leader for the EuroCC 2 project. Welcome to this hackathon, which is organized, as I said before, for a good cause. This event is held in collaboration with Cyprus Anticancer Society, and we extend our sincere thanks to them for agreeing to collaborate with us on this initiative. Without their valuable input, this hackathon would not have been possible. Let me start by giving you a brief overview of this hackathon. As the title suggests, Hack for a Good Cause, AI for Safer Drug Prescriptions. It's an event aimed at making a positive impact in healthcare. Specifically, we are focusing on improving the drug prescription process for hospitalized patients at palliative care centers through the use of artificial intelligence. Now why this is important? Well, many of us know about polypharmacy and that cancer patients are prescribed multiple medications, a situation, as I said before, that we call polypharmacy. When numerous drugs are combined, the risk of adverse effects increases, and this can be dangerous for patients. The goal of these hackathons is to develop an AI-based tool that helps tackle this issue. The tool will use patient treatment charts, which include details about medications, dosages, frequencies, routes, allergies, and comorbidities. It will also incorporate publicly available medicine leaflets. Using all this data, the tool will provide high-level alerts to doctors during the prescription process. This alert will help identify major drug interactions, contraindications with patients' medical record, and even potential overdoses. The ultimate aim is to ensure safer, more effective treatments for these vulnerable patients, reducing risk and enhancing healthcare. Now let me provide you with some key details regarding the hackathon. The event will take place from today until Monday, 14th of October, and giving us 5 days to collaborate and innovate. For any question on or technical support, we have dedicated Discord server available throughout the hackathon, where our team will be there to assist you. I'm also excited to share that we have 12 distinct teams and individuals participating, each participant from diverse research area. This diversity brings a wealth of knowledge and perspectives to the challenge ahead. and I'm confident it will lead to some truly innovative solutions. Let me walk you through the agenda for day one of the hackathon. We have begun and will continue with a series of presentations until 11. During these presentations, you will go from introductory presentations and information to more specific details about the hackathon. That means data set and the LLMs and so on. After a short coffee break, we will dive into hacking from 11:30 and onwards. Lunch will be served at around 12:30, followed by another hacking session until the evening. The day will conclude with more hacking and progress report at about 4:30. This agenda is designed to balance both learning and hands-on work. So we hope you are ready to engage and collaborate throughout the day. The agenda for the second day, which is tomorrow, Friday 11th. Again, we will start with a stand-up coffee, allowing everyone to settle and discuss progress. This will be followed by the hacking session, lunch, and then more hacking until 3:30. The day will again conclude with a progress report where teams will provide updates on their work. And also for day 3 and 4, which will fall on Saturday and Sunday, 12 and 13 of October. Hacking will take place remotely. Teams will have the flexibility to hack from home, continuing their work on solutions and preparing for the final day, which is on Monday. And on the final day, we will start at 9 with, again, stand-up coffee and regroup and discuss the final updates. And then at 9:30, we will begin with presentations. Each team will showcase their solution. And finally, we will conclude with the closing ceremony, and where we will celebrate the hard work and achievements of all participants. It's important to note that the winning solution will be announced after the thorough verification process to ensure its accuracy and effectiveness. This process will take place a week after the conclusion of this hackathon, and at which point we will announce the winning solution. Once validated, the team with the best solution will be recognized and awarded accordingly. It's important to note that all participants will receive a certificate of attendance from Cyprus Institute, acknowledging their participation and achievement in this hackathon. And also the winning team will also be invited to deliver a guest presentation here at the Cyprus Institute to showcase their solution. Additionally, they will be offered the opportunity to apply for some mentorship at the Institute, receive personalized mentorship from our researchers, and gain access to the Institute's high-performance computer, which is Cyclone. We look forward to seeing you the innovative solutions that will emerge from this event. If you have any question, I suggest holding them until we have gone through all of the today's presentations, as my colleagues George and Chris will provide more detailed information on the expected deliverables, data sets, or how to access HPC machine, and so on. At this point, I would like to give the floor to Mrs. Maria Ioannidou, the Executive Director of the Cyprus Anticancer Society, who has been a key partner in this initiative. Mrs. Maria Ioannidou, the floor is yours.
this is it. This is the presentation. I'm just going to say a few words. First of all, I want to say good morning to everyone. It's a really true pleasure to be here and to welcome you all to the Hack for a Cause. And on behalf of the Cyprus Anticancer Society, I want to express our sincere thanks to the Cyprus Institute. We truly appreciate the fact that you approached us with this idea for this hackathon and to have gone ahead and organized this event where innovation is focused on health. We also want to thank all of you who are here today, both physically and virtually, to support this event, and to all the participants who will be taking part in the hack for the work that we'll be doing the next 4 days. We are truly excited and look forward to seeing the results of the work that will be done, and of course how we will be able to implement this in the future to help healthcare professionals make better decisions and more timely decisions when they are treating cancer patients. So I think that events like this are crucial as technology is fundamental in the healthcare industry. I think this has been proven even more so with AI and the advancements that we see in the last few years. And this is necessary in advancing healthcare services in all aspects and ultimately improving the lives of those in need. Today, we stand at the intersection of technology, I believe, and initiatives like this hackathon demonstrate the incredible potential we have to create real change. I want to say just a little bit about what we do at the Cyprus Anticancer Society for those of you who will be taking part in the hackathon. We're an organization with over 50 years of presence in Cyprus. We're one of the first nonprofit organizations in Cyprus with a mission to improve the quality of life of individuals with a cancer experience and support their families and caregivers through specialized support and palliative care services throughout their cancer journey by providing specific services that are essential at any specific time throughout their cancer journey. At the same time, we advocate for their rights, providing information and engaging in research and in education. Our vision is that no one with cancer will be alone throughout their cancer journey, and this is at the heart of everything that we do. As an organization specializing in palliative care, we provide both home care and inpatient care. We have an inpatient hospice that many of you have heard, Arodafnousa here in Nicosia, and we have a daycare center, the Evagorio in Limassol, and we also provide, as I said, home care services throughout the island through our regional offices that we have in all the regions in Cyprus. Our focus is not only in providing physical care, but also providing physiotherapy, social services, and psychological support as we focus on the overall well-being of those that we serve. Cancer is a journey that comes with immense challenges, physical, emotional, psychological, and even spiritual. And one of the greatest daily challenges healthcare providers face, and that individuals with cancer experience, is the issue of polypharmacy, which is what the focus of this hackathon is all about. Polypharmacy refers to the use of multiple medications by a single individual, often necessary due to the complex treatments required in cancer care. While each medication may be essential to treat a specific aspect of the illness, the interaction between these drugs can be incredibly risky. Those undergoing cancer treatment often face a combination of medications for pain relief, chemotherapy, antibiotics. And this becomes even more challenging when there are also other treatments for comorbidities, such as diabetes or hypertension. With more medications, of course, you probably all understand, comes more risk. Contraindications where one medication negatively interacts with another are a daily concern for healthcare professionals. These can result in dangerous side effects, reduced treatment efficacy, or even harm to the individual. The challenge is not just avoiding mistakes, but creating a system that anticipates and prevents potential errors before they happen. This is where technology, particularly artificial intelligence, can make a meaningful difference and help healthcare providers in the safest drug administration or dosage. As you work on this project, imagine the daily experience of an individual with cancer, already coping with the emotional burden of their diagnosis and the physical toll of treatments, only to be faced with medical complications. Whether it's an adverse reaction, an incorrect dosage, or a contraindication that worsens their condition, These are not hypothetical situations. They are real, faced by patients that we serve. So addressing polypharmacy and improving medication safety is essential to enhancing the quality of care that we provide. As healthcare providers, we constantly seek ways to reduce risks and improve the treatment process for those that we care for. Without advanced tools, these challenges can be overwhelming, even for most experienced professionals. This is precisely why events like this hackathon are so important to us. What is special about this hackathon is the opportunity that it presents to develop solutions that will directly address these challenges. By focusing on creating an AI tool capable of identifying potential drug interactions, contraindications, or even overdoses, we are moving towards a future where individuals receive safer, more accurate care, and where these issues are dealt with proactively. I want to take a moment to acknowledge the incredible range of expertise gathered here today, from healthcare professionals and researchers to technologists and developers. Each of you brings a unique perspective and skill to set to the table. It is through interdisciplinary collaboration that true innovation flourishes. I have no doubt that the solutions created during this hackathon will not only benefit the Cyprus Anticancer Society, but could also have a far-reaching impact across healthcare systems in Cyprus in general. I'm sure that this event is just the beginning. The ideas and innovations that emerge here have the potential to ripple through our healthcare system, creating a future where care is smarter, more efficient, and more importantly, safer. Your work here will touch lives, making the treatment process even easier for healthcare professionals and ultimately making the experience of those with cancer more manageable. While we cannot eliminate all the challenges that come with cancer, we can certainly reduce the risks, improve safety, and make the journey smoother for those already facing their cancer journey. I want to thank all of you for being here today. Your passion, expertise, and dedication are truly inspiring to all of us. We've worked with George Kyriaki the last few months, and we truly appreciate all your help and support in putting this together. And we truly thank the Cyprus Institute for having this thought and putting it forward and making it a reality. So as you begin your work, and this is to the teams, keep in mind the real-world impact your innovations will have. The tools you create today will shape the future of care, bringing us closer to a time when no person with cancer experience will have to worry about the dangers of polypharmacy or contraindications. We're eager to see the amazing solutions that you will develop. And together, I think we can push forward, push the boundaries of what's possible and make a meaningful difference in the lives of those that we serve. So best of luck to all the participants in the groups in the hackathon, and we look forward to hearing the presentations that will come at the end of the hackathon. Thank you all for being here.
Hello, everyone. Good morning. I'm Yorgos. Again, good morning. Today, I will talk a little bit about the setup for this hackathon and how you will hack for this cause. I'm Yorgos. I'm a research engineer here at the Cyprus Institute under Castor C and part of the EuroCC project. And if you want to talk to me about anything, you can reach me on that email. In this presentation, I'm going to talk a bit about what our datasets look like that the Anticancer Society has graciously given us, and then what we expect from you to give us back from these datasets, and then some tools that you can use, and a bit about the setup we made for you on our supercomputer. And let's start with a patient file. This is for a single patient, and you can see 3 tables. And the leftmost big one is the medicines list. As you can see, it has a huge list with medicines. On the right side, you can find the dosage for each medicine, the frequency that that patient takes that medicine, and then at the end, how they take it. You'll see a lot of acronyms, and in the spreadsheet of those patient files, there is a glossary where you can find explanations. There are 2 tables on the right, one for allergies. This patient doesn't have any. And then there are coexisting conditions. So on top of their cancer, they may have other conditions. And what we expect from you out of this dataset is to extract those interactions on the bottom left. So for this patient, they have 3 major interactions that the doctors are careful when administering those medicines. This spreadsheet is on when Chris will show you later to log in on Cyclone. There is a directory named Hackathon, and inside that there is a Hackathon XLSX file, which is a spreadsheet. And you'll also be given a small script to extract all of this data into a data frame per patient. And then on top of those medicine files, of those patient files, you'll be given the leaflets that come with the medicine in their package. There is another folder called medicine files in the Hackathon directory with a list of PDFs. And as a starting point, you'll be provided with a small script to start extracting that data. I'm not going to give you any more info, but you are free to expand this data set on your own. Since there might not be enough information in there, I'm not going to give any more tips. So yeah, you're free to do so. One thing about the Hackathon directory, it should be read-only. So any files you download should be on your account. The Hackathon is a shared directory one, so you don't want to share any datasets with other teams or any solutions with other teams. And one of the challenges that you will try to overcome is that some of the patient files are not entirely consistent since they weren't machine generated. So one doctor might write haloperidol with an E and another one without an E. So you need to be careful about that. Another challenge is that most of the medicine leaflets have a lot of useless information. As you can imagine, if you ever open that leaflet, you would be looking at it for 5 minutes until you find what you need. So you need to be careful on which part of that document you focus on. And now a bit about what we expect from you at the end of this hackathon. I will expect from you a list of interactions per patient. I will show you an example in the next slide. And the code that generates that list, so we can test that you didn't actually do it by hand. And the deadline for those 2 is on Sunday at midnight. And then you will be giving a presentation, as Kyriaki said, on Monday to explain your methodology and your solutions. And the winner will be announced in the near future. So this is what we expect from you. It's a simple JSON or Python dictionary, whatever you might call it. As you can see, we have a key with the patient as it's the name on the Excel sheet. So for patient 2, it's patient 2. And then there is a list of interactions. And what we expect from you is to find the major ones. So those are the ones that the Anticancer Society has is actually aware of, and they consider that those are the major ones. But when I was doing some sample solutions for this hackathon, I found a lot of false positives, or I call them minor ones, and those were detected because in a lot of those medicine files, you'll find something along the lines of talk with your doctor if you're taking X along with Y. So those should be provided in there, but you should put the severity as minor. So that will act as a warning to the doctor to think about the prescription again. And if you give us the explanation of that interaction, so that might be the context of where you found that interaction, you will be given extra points. So some warnings about the main deliverable is that if you try and iterate through all possible combinations of medicines and allergies or coexisting conditions in a patient file, you'll probably run out of time because it's a huge number. If the patient has 13 medicines and 4 and 6 coexisting conditions and 3 allergies, you'll need to run about 100 different combinations. So don't quote me on that number, I'm not sure. So you will need to use the whole patient file or big parts of it to limit your requests. And as I said before, that thing about the minor interactions, be careful about that. Some more detailed explanations about this will be provided to you in the GitHub repository. We'll share with you after our presentations. So if you have any questions, read that, and if you don't understand, talk to me. And now let's talk a bit about how you should solve the problem. And that's the process I described a bit before. It's you will read through the patient files, patient by patient, and then extract the important information you will use. Then you will match that information with the appropriate parts from the medicine leaflets or any other data sets you may create. And then you will use an LLM to give an answer in the form I showed you before. So that JSON file should either be generated by an LLM or have a script that changes your LLM generation to that format. And how you can do that is by using what we call RAG. RAG is a retrieval augmented generation technique, which based on the information you receive from the prompt, from your own data set, you give that information you retrieve to the LLM to generate a response. And this is usually used when you don't have enough data, when you don't have enough data to actually create your own model or fine-tune a model. So you want answers that are based on context that the model wasn't trained on, so it doesn't have that knowledge. And so for this hackathon, how to use RAG is you will retrieve the, let's say the medicine leaflets, the medicine leaflets that are appropriate for the medicines that the patient is currently taking, and then ask the question if there are interactions within those. This is what I said before. A base model, you might prompt it, what was the name of that movie Chris emailed me about last year? And of course, the LLM won't know that. Yeah, it doesn't read your emails. But if you actually connect that retrieval part I talked about to to your prompt before giving the prompt to the LLM, you will retrieve that email and give it to your LLM as context, so it knows where what movie Chris emailed you about. And these are some tools that are really useful for creating RAG systems. First of all, it's LangChain. It's a whole LangChain toolkit, but LangChain is the main one you will use to actually create your prompts. So you would say you will have a string with your prompt, and then you will just use a pipe character in Python, let's say, and then the LLM, and you will get back the answer. And there are many other features, and I don't have enough time to talk about them, but more information for these can be found on the GitHub as well. And then there is LangGraph, which you can create, is used to create some more sophisticated LangChain chains. So you can make decisions on which prompt to actually use, depending on the answer of a previous prompt, which will be really useful for your case. And then there is Langsmith, which it's really helpful when debugging these RAG systems, because it will give you a graph of which documents were retrieved based on your information, and then which prompt was prompted. And then there is Olama, which is what you'll be given for inference of your LLMs. Chris will talk a bit about later on how to use that, but you will have a container running on Cyclone for each group with your own inference server. And you will have these 4 models available. We chose one from each big company. So the biggest one we have is the Gemma from Google or Alphabet, Llama from Meta, the Phi from Microsoft, and the Nemotron from NVIDIA. And each group will have 1 GPU and 10 cores each, CPU cores. And that GPU is a V100 from NVIDIA, so you'll have 32 gigabytes of VRAM where you can load those models. I think the biggest model here is 12 gigabytes, not that sure, but it will actually fit on that GPU. But if you increase the context size of your prompt, you'll find out that you will run out of VRAM really fast. So be careful on which models you choose and what the context size of each model you set that to. And if you have any questions, please ask now or later in the Discord server. You can mention me with that tag there. If any of you isn't on that server, we send you an email with an invitation. So you might need to check your emails, or if you didn't find one, send us an email and we will add you. Do you have any questions regarding the deliverables or the setup? Anyone online? Yeah, you probably have some more questions later on, so thank you. And now we'll give the podium to Chris. George, is this okay?
Hello, good morning, everyone. Thank you all for being here. Just a question, how many of the participants maybe used in the past Cyclone or any other HPC machine by any chance? Okay, that's good. So this session basically will cover how to access the machine, what you need to do before you access it, and then how you can effectively launch your Jupyter notebook that you'll be running your tutorial or your hackathon on the compute nodes of the Cyclone. So Minas already, or the HPC facility in general, sent you instructions on how to create your SSH key. If you haven't done that, please let us know after this session. This session initially was like 40 minutes, but because you'll need to log into the system, maybe I'll just go through the presentation and I will provide you support to the next room afterwards so that you log onto the system. Okay, so my name is Chris. I'm a research engineer here at Castor C, and my expertise mainly lies in high-performance computing. For any of you that will be accessing the GitHub repository George mentioned, I've just made that public. It's on our account on GitHub, Castor C CYI, and you'll see a repository called EuroCC Hackathon. There you'll find George's presentation and mine, and also some extra material for the hackathon. So what's a supercomputer? Effectively, if you put a lot of computers together, you end up with something like that. If you connect them with a fast interconnect, then you have a really fast machine that can cover a lot of computations at a very short period of time. This is Lumi, by the way. It's in Finland. It's Europe's largest supercomputer, and it's amongst the top 10 supercomputers in the world. Now, what do you have inside the supercomputer? Effectively, you have what we call compute nodes. You can think of these as drawers. Each one has maybe some GPUs, some CPUs, a lot of RAM. You don't really have like hard drives with that. Maybe voltage converters. You have all that centralized in long-term storage and power supply. And on the right, you have your traditional desktop, maybe with some CPU and GPU, some RAM. And usually, like as a rule of thumb, this is not always the case, but most of the cases, a compute node, it's roughly 5 times faster than a traditional desktop, like a high-performing desktop, let's say. So this is really good if you want to accelerate your computations effectively. Now, if you start with a compute node, and then you place a lot of them together, then you have what we call a rack. So this is some terminology maybe if you need it later on. And if you put a lot of racks together and you connect them with a fast interconnect, you end up with a supercomputer, right? And this is what really interests you, let's say. So the architecture of the HPC system, maybe I can. Yeah. Okay. So first you start with, this is you. This is your terminal session. This is your laptop, let's say your computer. This is a Unix shell on your local machine. This is the head node of the system, and this node is shared when you access the supercomputer. This is shared by all users that are using the supercomputer at the same time. So just some etiquette, please don't run anything heavy or long on that node. What you can do instead is, you can use the compute nodes. We have a lot of compute nodes. This is for executing workloads. The resources there are scheduled, as I'll explain later, and the resources are explicitly per user, right? Now, if you can use these slides to get access on later on Cyclone, but just to give you like a brief idea, first you need to set up a configuration file where you sort of add the host name of Cyclone, your username, your key that the HPC facility asks you to provide. And then once you do that, you should open a new terminal session. You just write SSH Cyclone, and you should be transferred to something that looks like that on the right. So this is the login node of Cyclone, and you'll see down there that your username and front02. That means you're located on the front node of Cyclone. If that doesn't work, we can deal with that as we go. There are some caveats that you might face, but just to check, when you do the ls command down there, you should see a directory named Hackathon. This is the directory George mentioned about that is read-only, and you can find the information of the hackathon there. Just a quick note, if for the Windows users here, if anyone used PuTTY to generate the SSH key, you'll need to convert that into a different format. I'll show you how this is done, or you can find the information on the facilities website. So all HPC systems using what we're calling a scheduling system. So this is basically a job scheduler for managing and allocating resources to each of the users. On Cyclone, we're using Slurm. And Slurm basically is responsible for job scheduling and management, resource allocation, and monitoring your job status and so on. A basic workflow is you're submitting first a job. This is using SBatch. Then you monitor that job, how it goes, if it's running or if it finishes and so on. And once it finishes, the results are becoming available to you, and you could see the results of your computations. I have placed here a few useful commands that you might need during the hackathon, some for job submission, like SBatch and the script that you want to run. SQ basically shows you what's currently running on the system. If you do SQ minus user and your user ID, effectively that will show you what jobs are running for your own user. And then there are some other, if you want to cancel a job, maybe you can do as cancel the job ID and so on. So this is just some housekeeping you can use. Now, I've mentioned about launching a job script. What's this effectively? So this is, you can think of it as a bash script that basically has what you want to run, which is all these things down here, and some additional housekeeping for the scheduler to know what it should do with that, right? Okay, so first you have the job name. This is Hackathon. So we're providing you with that, so you don't need to do anything. You just need to run that, right? You have the job name, you have the partition. This means you'll be running on the GPU parts of the system. You're using one node, as explained earlier. And then each team is assigned with one GPU. So this is shared for the whole team. And then some results will be outputted to your home directory as you run it. So if you launch this script, it will actually run for 24 hours, right? When you finish your day with the hackathon, feel free to cancel that job that launched it, and you can launch a new one the day after that. Also, we've created a reservation for you, Hackathon. This is just to get your jobs priority to the queue, so that you don't have to wait for it to run. So you only have to launch the script once, right? Okay, so now I'll just go through the process of how to launch the Jupyter Notebook on Cyclone. This is only one user from the team should do it, and then the rest, once you launch that, you can access it from your own browser, right? First, you launch on Cyclone. You launch the launch hackathon.sub. This is the file that I showed you earlier. Basically, you'll see something. You'll do something like that. It gives you that you submitted a batch job with some ID. You can see the status of your job. Mine is set to R at this time, so it means the job is running. And then if you do ls on your home directory, you'll see a few files being generated. This is for logging and stuff. You don't need to do anything with that. The only file we're interested in is actually the connection info.txt. This will show up a few moments after your job starts running. And effectively, it will give you some instructions on how to set up an SSH tunneling. So effectively, a connection of your laptop to the Cyclone machine, and then some URL for accessing the notebook on your browser. and the model endpoint that you should ping for you to use the LLM that George mentioned earlier. So this is, if you open the file, this is a TXT file. If you open it, you should see something like that. We just need parts of this information as we proceed. So once this is showed up, this is the SSH tunneling that instruction we'll be using. I'll show you how. And this is the URL and password that we'll be using for launching the Jupyter Notebook on the browser. And finally, this is the model endpoint. I'll show you when you need to use that, right? So once the file is created, once you open it, then you should go and open a new terminal session. And effectively, what you'll do is use the tunneling command I'll show you now. Effectively, this is a long SSH command. And this will just generate some sort of connection between your laptop and the Cyclone machine. That's the only thing that you need to do for that. Then you proceed, you open a browser, you're using the URL that was provided in the connections TXT, and you'll be asked to provide a password. This is also provided. And then you should see something like that on your browser. So this is your home directory on Cyclone, right? This is showing the hackathon directory that George created with all the content from the hackathon. And these are the files that have been created when I launched the job. So this is what you need to have in front of you at this time. Then you can, if you navigate the hackathon directory here, you just go to hackathon and you'll find an example Jupyter Notebook. This is just showing how to configure the Olama for inference, and then how you can prompt your local LLM, right? What you need to do is just change this line here. The first line is called Olama endpoint with this part of the instruction here, the HTTP that serves the model endpoint. And then you just feel free to run the kernels. And what you'll see effectively at the end is, some AI generated message. That means that you're set to go. Your connection is working. Your Jupyter Notebook is running on Cyclone, and then you're good to go. You can create your own notebook and start working on the hackathon. Once you reach this point, remember that everyone in the team can now access this URL. So feel free to share it with your colleagues in the team, and then you can all start working on the hackathon together. Do you have any questions? If not, maybe we can move to the room next door and we can just get started on configuring your own solution, and then we can get it from there. Thank you.